Unacademy. Let's crack it.
Hey everyone, welcome to this session. Very good evening to all of you. My name is Sandeep Singh, and I have like 10 plus years of IT industry experience. And today's topic is like tips to crack product company. Like, what are the things we should be keeping in mind for getting into our dream company or product company, right? So agenda would be like I will be talking about. First thing is DSA introduction, importance of DSA, right? And like what's the importance of HLD and LLD, right? And then I will talk about the multi-pager resume and single pager, and then how we can create single page resume, right? So this would be the agenda for next 1 hour session. Okay. So first of all, I just wanted to tell you about the DSA importance, like why data structure and algorithm is important for us, right? Why product companies or good organization they are very interested into the DSA, data structure and algorithm, right? So generally what happens, like you can see that if I talk about the first thing is like what exactly the data structure, what exactly the algorithm is, right? So just let's take a layman example. For example, you have some input, you have some you need to generate some output based on some logic, right? So if you can see in this box, right? So if you can see in this box, so this is the logic, this is the logic which I'm going to implement on that particular input, right? And this is my input, this is my input. Like let's say maybe a simple example, we just wanted to calculate 2 into 2, the output should be 4, right? 2 into 2 and output should be 4. So input would be 2 and 2, and the logic would be, the logical operation would be into multiplication, right? That would be the multiplication. And then, so let's say for example 2 and 2, this would be the input, and I'm passing this input to this particular logic. It and it will generate, it will apply this particular operation on these inputs and generate the output, and output would be 4, right? So 2 comma 2 would be input, into would be the logic, and 4 would be the output. So if I see here, so there is input, there is output, and then there is logic. So for storing or for representing the input, we need a data structure, right? Like somewhere we need to store that value. It means whether it's an integer, and this input can be of any type, like maybe an integer or string or long, double float, anything it can be, right? So for storing that input, we need specific data structure, we need specific data structure, and that is the data structure. And this multiplication is an algorithm, and that is the logic, and this is the algorithm or this is the logic which you are seeing into the box. So 2 comma 2 would be the input, this would be the logic, and this would be the output. So we need data structure to store that input, we need data structure to result that output, we need some algorithm or logic to do some operations, right? So this is a very basic understanding of DSA, like why do we need data structure and algorithm. So like for example, maybe this input we can store it into, let's say, a linear data structure or non-linear data structure. So we just wanted to use efficient data structure, right? We just wanted to use efficient data structure. Which data structure would be suitable for that particular input, right? Or whatever output we are generating, for that also there should be appropriate data structure so that we can store that output into that particular data structure. And if I talk about the logic or algorithm, so our algorithm should be like, we can the operation or the functional logic, right? Or the whether it's a mathematical computation or maybe any business logic or whatever it is. So that should go as part of a logic or our algorithm, right? So this is about a very basic example of DSA: input, logic, output. So this would be my algorithm. This would be, there would be a data structure to store input, there would be data structure to store output, right? Now the thing is, why DSA, right? What's the importance of DSA? So the first thing is, if you know proper data structure, if you know proper algorithm, then definitely you will be able to write optimized code. You will be able to write better code. Okay, so it means, like, for example, um, let's say if you want to build an optimized product, or if you want to build a product from scratch, so for each and everything you should be keeping in mind, like, which data structure I should be using, which data structure will be appropriate, right? Like, maybe for linear data structure we can go for the array, like, for example. So what's the exactly requirement we have, right? Maybe a quick searching, or maybe a quick insertion or deletion. So based on the requirement, based on the logic, we can choose the data structure, right? And then what exactly the requirement is, so that we can apply that particular algorithm on that data structure, right? So that's the thing. So that is the thing, for any optimized product development, you need to understand the proper data structure, what kind of data structure you are going to use, and what kind of algorithm you are going to use. That's the reason there are multiple data structure, like linear, non-linear, multiple algorithms are there, right? Multiple algorithmic approaches are there just to solve a specific problem, right? If I want to solve a specific problem, I can't say that whether this algorithm is right or wrong, right? Because everything is meant to solve some problem, correct? So that's the reason we have different variety of data structure, we have different variety of algorithm, right? So the first benefit, or the first importance of learning data structure and algorithm would be, it would help you to write better and optimized code, right, for your product development. Now the second point is why we should be learning, because whenever, if you want to let's say if you want to go to your dream company, and definitely they would focus on what I would say, they would focus on core DSA, right? Like how the data structure and algorithm knowledge you have, right? So you should be having a sound knowledge to enter into any of your dream company. So that should be the second thing, that should be the second importance of learning data structure and algorithm. So better and optimized code for better and optimized product. And the second thing is, definitely big companies or big product development companies, they want their product, because their product needs to be scaled, right? It should be highly scalable. So if you're not writing an optimized code, if it is not having a proper scalability solution, then definitely there won't be a better user experience, right? So that is the reason, like, big companies or big product development companies, or if I can say that, good product development will require a sound knowledge of data structure and algorithm, right? So now I just wanted to give, just to relate this, I just wanted to give a data, one more example, like, let's say a document search, okay? So in document search, for example, maybe let's say there is a document, okay? There is a document, and in that document there can be multiple numbers are stored, okay? There is a multiple number. There are 100 pages of this document, but this document is not sorted, right? This document is not sorted. It means maybe in the first line the value would be 90, right? And in the last line of this page the value would be 2, right? And similarly there would be a pagination, and there can be up to 99, from 1 to 99 pages, right? Now if I ask you to search any number, so there are multiple approaches, right? So one thing, how can we search that? So one thing we can search, like, let's say if I want to search number 5, if I want to search number 5, okay, so I don't know where exactly 5 is lying, on which page, right? So what options we are having? One first option, like just keep on reading line by line till 100 page, and whenever I get that particular number, I'll just return it. Okay, so this number is available onto this particular page, or page number 49 or page number 50, right? Okay, so this approach is brute force approach. If I will tell you, like, this approach would be brute force approach. Okay, now the thing is, so iterating, right? So iterating from line number, or from page number 1 to page number 19, it would be more time consuming, correct? It would be more time consuming. So the thing is, going, because let's say if you're doing manually, then how you would be doing that? You just keep on scrolling, right? Keep on scrolling the pages, keep on reading the line, and then keep on scrolling, and whenever you get 5, you can just return that value, right? Okay, I got it. Okay, this number is at 49, and I can just return this number. I can tell you, okay, this particular number is available on page number 49. Here there is one problem in this approach. The problem is, it's time taking, right? It's time consumption. So it means the time complexity of this problem would be high, right? So let's try to solve this problem in a different approach, or in different way. So let's say this, because we know that this document is not sorted. For example, let's say by using some mechanism, or by using this box, which logic or algorithm which I have written here, this box, if by using this particular logic or particular algorithm, if I can sort the whole document or the whole page from 1 to 100, right? Sort from 1 to 100, then what will happen? And what will happen? Now this is sorted, right? Now it is sorted. So if I can go to a specific page, like let's say a page number 5, okay, if I'm going directly to the page number 5, I can read the first row of that particular page. If I can see, oh, this page number 5 is having, let's say, value 45, okay, so let's say value 45, then definitely 5 is less than 45, right? Definitely 5 is less than 45. So it means whatever value which I'm looking for, that is not beyond page 5. It means it's just before page number 5. It's before page number 5, right? So that's how, so first thing here, in this approach, we have followed two things. One thing, we have sorted the whole document. So that we call it as a sorting algorithm, right? Any kind of sorting algorithm, you can use it. It's up to you. I'm just giving an example. So you can use any sorting algorithm to sort that particular page, right? Okay. And now this strategy, if I go to page number 5 and the first row, if I know that the first row value is 45, it means I need to go back, not forward. So this we call it as a binary search. Okay. So here I have used sorting for sort this whole document, and I'm using searching for searching that particular element. So what I'll be doing, let's say my search window is from here to here. I'll just find it out the mid value, and then again I will, based on this mid value, I will divide my array, and then again I will find it mid value, and similarly I can just keep on searching, or keep on checking into the smaller window, right? So that's how I can make my search faster, right? That's how I can make my search faster, right? So if you guys have any problem, any question, maybe you can just put into the chat. Okay, so I hope this example is clear, like find number in given unsorted document. So what we have seen there were two approaches. First approach was just going one by one, row and page by page. It means like this a brute force approach, just and keep on iterating it. In the second approach, I've just followed sorting algorithm, and then I'm just following searching algorithm. So two algorithm I'm using. So this box is about the sorting algorithm and the searching algorithm, right? So this box will talk about the sorting and searching algorithm. And what was the input? I had input to find or to search number 5 in this particular document. So I will be giving two input. One thing is like I'll just pass the whole document, right? And the second argument or second input should be the desired number which I'm looking for, and the output should be like on which phase it is available. So that should be the output. So now you can understand that, right? So the logic or algorithm is your sorting algorithm and searching algorithm, and data structure is like where exactly you are storing that particular input, and data structure, which data structure you are going to use to produce that particular output, right? So I'll just repeat it one more time. So what's the importance of data structure algorithm? So first thing is, yeah, definitely to land you in your dream company, and the second thing is to write better product or to write optimized code. Okay, so this is the reason why companies focus on DSA. So it's not for only for the freshers, it's for experienced people as well, because generally the company, they are like kind of a language agnostic, because they don't bother like which language you are writing or which language you are uh, um, uh, which you are aware about, because they bother about your core concept or the basic concept, and that is like data structure and algorithm. So if you know it better, then you can write in any of the language, maybe a .NET, PHP, Java, any of the backend language, you can choose it, and you can implement the basics. It means the data structure and the algorithm, right? So this page was about DSA importance. Okay, so now we'll go to the next page. Okay, so now I just wanted to talk about design importance. Like, what's the role of system design? Okay, what's the role of system design in any of the interviews? Like, let's say if you're going for the interview of any of the companies, then majorly 2 point is like, first thing is DSA. They will be checking your DSA knowledge, your data structure and algorithm knowledge. And the second thing is very important, which is like design. Okay, so design, we generally categorize it into multiple things. Like, first thing would be LLD one, and the second one would be HLD. Okay, so LLD and HLD, right? So LLD or HLD, what exactly do we mean by LLD or HLD? So as the name suggests, LLD, it means like low level design, and HLD means high level design. Okay, so let's say, for example, if I talk, or maybe let's say if I tell you to design, for example, let's say parking lot. Okay, so how would you design parking lot, right? So if I talk about designing parking lot in terms of the LLD, then what I will be expecting. So schema design, that is the first thing. Your class design, that is the second thing, right? How you are designing your entities, okay, and how your entities are kind of, how's the entities relationship is there, right? How's the entity relationship? Like, maybe it's kind of one to one, maybe one to one, okay, or maybe it's kind of one to many, okay, or it can be many to one, okay, it can be many to one to many, or it can be, for example, many to many, right? It can be many to many. Okay, so something like that. So like, for example, maybe I can say that a person a person a person can have multiple address, right? A person can have multiple address. So multiple address, it means like he or she can have maybe a home address, okay, and maybe office address, right? A person can have home address and office address. So one person can have home address, one person can have office address, right? So it means like one to many relationship. Okay. Now the thing is how you, while designing your entity, you should be keeping in mind like how your attributes are there, right? How your features are there, how your methods are there. Okay, like and what kind of, what's the primary key, what's the foreign key if you are using a relational database, and what's the primary key, what's the foreign key. Those things you should be keeping in mind while designing your entity relationship diagram. Okay, so the first thing is schema design, the second thing is definitely the entity relationship diagram, and the third point is oops concept uses. Like definitely you should be very much clear on how would you use object oriented programming language if I'm talking about maybe a Java or C++ or object oriented language, right? So like let's say for example, when you'd be using abstraction, when you'll be using interface, what, right? So those things you should be clear on that while designing your LLD, right? So that where you'll be using interface, where you'll be using abstract, when you'll be using inheritance, right? Polymorphism and all those things while designing the LLD part. Those things you should keep in mind. Okay. Now the thing is, if I talk about, then definitely for LLD, design pattern is very important, right? So design pattern is very important. In terms of the design pattern, there are like, for example, on a high level, we have like creational design pattern, right? We have behavioral design pattern, okay? And we have structural design pattern, right? So these are the different design pattern, and using these design pattern, we can build our entity relationship diagram or our LLD, okay? Like maybe in some cases, maybe for creational, let's say singleton would be better, or for some use case there can be a prototype, okay? Or maybe visitor pattern might be useful for some of the use cases, right? So we should be having a proper understanding of each and every design pattern so that we can implement those design pattern into our low level design. Okay, so again I will repeat it one more time. So for LLD, definitely the schema design, the entity relationship diagram, object oriented programming concept, how you are going to use it, and then design pattern uses, right? What are the different design patterns are available, and then how you are going to use it, how you are going to implement it to solve a specific problem or to design your LLD, right? Because each and every design pattern has been meant for solving a specific problem, specific use case, right? So that's about your design pattern uses. Okay. Now, the second, in any interview process, there are two kind of a designing. First thing is a low level designing, and the second one is a high level designing. So what exactly do we mean by HLD or high level design? Okay. So in HLD, so it means, so it's high level design. Like let's say maybe I can ask you to design, for example, let's say similar like Google Doc, okay, or maybe for example a messaging platform like Facebook Messenger. Yeah, similar like a messaging platform, for example. Okay, so now the thing is, whenever we are going to design any high level design or any system design, and how we are going to do that, the first point is functional requirement. Let's take an example. Okay, let's take an example. Let's say if I'm going to use maybe messaging platform, okay, WhatsApp or Facebook Messenger, then what is the functional requirement, right? We should be clear about our functional requirement. So the functional requirement, maybe it can be, first thing is like one-to-one messaging, okay, one-to-one messaging. The second point or second functional requirement or second FR can be maybe a group chat, maybe group chat, right? Second, and the third one, maybe we can talk about the chat persistence, right? Maybe we can talk about the chat persistence, right? So similarly, we can talk about there should be some feature where we can track online status, right? Online status, then maybe offline status. Okay, sorry, my mouse pad is like, yeah, online status, offline status, and then maybe we can see that last seen. Okay, maybe we can see that last seen. So something like that. So we should be clear about functional requirement, how our functional requirements are there, right? Then only we will be able to think about those features and how we are going to build those features. If you are not clear about the functional requirement, then how we are going to build that solution, right? So a very important point in HLD or high level designing the functional requirement, right? Now the second point comes like non-functional requirement, how the non-functional requirement will work. Okay, so the non-functional requirement, will tell like my application, my production should be highly available. It should be highly available. It should be scalable, right? It should be scalable. Then it should be kind of, there should be latency should be minimum, right? Minimum latency. For example, minimum latency, right? Minimum latency. Okay. So my product should be highly available because I am going to maybe there can be like, let's say 600 or 700 millions users per day. Okay. So I need my system to support those many requests, right? Okay, so that is a very important point, like how you are going to support. So your system or your product should be highly available, it should be scalable, there should be a minimum latency. For example, like let's say you have WhatsApp account, and your WhatsApp account, maybe you would have logged in into multiple devices, let's say mobile devices, and then maybe you would have logged in into a web browser and let's say some other devices as well. Okay, maybe in your watches and all, and maybe your smartwatch. Okay, so these are the different devices, these are the different channels. So let's say if I am sending a message to you, okay, so if I'm sending a message to you, your message should get propagated at same point in time to each and every devices. It means mobile devices and the web browser, right, and your smartwatch. Okay, so for that reason, that so they can tell you whether it's a part of a functional requirement, or maybe a minimum latency can be part of a non-functional requirement. So just I'm giving you example, like the functional requirement and non-functional requirement should be clear. Okay, it should be clear. So if we are clear about functional and non-functional requirement, then we will be able to solve that problem, because we know the problem better, right? Now we'll find the solution. Now the third point is very important point, that is our capacity estimation. So capacity estimation, it means like how the disk uses, how much disk we want, how much storage we want, how much CPU we are going to use, how much what should be our processing capacity, how much data we are going to process it, right? So that is very important point, like capacity estimation, like how would you estimate its storage, how would you estimate the storage, like how much storage you want, right? How much processing, how much power you want to process that particular request. Like let's say maybe I can say that for this particular capacity, maybe let's say for example there are 600 million users. Okay, 600 million users are there, and on an average, let's say one user is having, for example, maybe 50 message. Okay, so 600 into 50, there can be some number, and those many messages would be there, and on an average, if I can say that this message will be of particular fixed length, then I can calculate the storage, right? Similarly, I can calculate the processing power as well, like how much CPU want, right? Because whenever you are going to any of the cloud, then you will be asked like how much disk space you want, how much core you want, okay, how much processing power you want, whether you know whether you need 2 core machine, 4 core machine, what kind of series of machine you want. So that much thing, so those are the very important point while provisioning the infrastructure. Okay, so you should be estimating your capacity, how you are going to estimate the capacity, right? So that you need to calculate it, how much storage you want, how much CPU, how much processing, how much core CPU core you want to process your request, right? So we talked about the functional requirement, we talked about the non-functional requirement, and then capacity estimation. Then generally in HLD we talk about API design as well, right? So in API design, how our API design should look like, okay? So in design, mostly, generally we take care of the API endpoint, how our endpoint should look like, what kind of parameter it is taking, right? What kind of query param, maybe path param, what kind of output it should be, whether it should be XML or JSON or it should be protobuf, right? So these are the different formats which we can accept and which we can produce it, right? Okay. So, and how we should be defining our endpoint, that is very important point. Your endpoint should be you should be following a proper practice or best practices to write your API endpoint. And how would you secure your API? Correct? How would you secure your API? Means how the API security will work. How the API security will work. It means like what kind of security mechanism. Maybe it can be a business to business security, B2B call. Maybe it can be B2C, business to customer call. How you are going to handle those many API requests or those many API security. Okay. Now in HLD there is one more very important point, and that point is like what kind of database you are going to choose. Okay, so that's very important. So each and every database, either if you are talking about the SQL or any category of NoSQL, every database has been meant for a specific use case, right, to solve a specific problem. Okay, so we should be identifying what is our problem and which category we want to go in. Maybe we can solve that problem using MySQL, or maybe we can solve that problem using NoSQL. Okay, so maybe SQL or maybe NoSQL, right? Now the question is, if I'm going for the NoSQL, then again there is a subcategory like what kind of database we are going to use. Either we are going to use document based, or maybe a columnar family, or maybe graph, or maybe a key value store. What kind of document? Let's say if I'm going for document, then maybe I can choose for MongoDB, or maybe for columnar family I can go for the Cassandra, right? For graph I can go for the Neo4j, so something like that, right? So the database is also very important, because while designing your entity, how the relationship should be there, that is very important, like to decide which database you are going to use it. Okay, so this is also a very important point in HLD or high level design. Okay, now generally what we do, we talk about our high level component, like let's say maybe we want load balancer, we want our API gateway, right? Maybe we can have our caching, or maybe we want to use some event driven approach like messaging queue, or maybe a Kafka or something like that, and then database. So there should be a proper block diagram, proper component diagram, which we can represent it. Okay, so this would be the high level diagram. These many load balancer, this is the gateway, there should be a service discovery, how the caching, where exactly the caching will work, what kind of caching strategy we are going to use, right? What kind of event driven approach we are going to use it, what kind of messaging platform we are going to use it, right? What kind of database we are going to use it. So these are the things, a very important point for kind of to do this, right? So this high level component. Okay, so now the thing is, now I'll just reiterate it, like the design importance. So the first thing is we talked about the LLD part, and the second point is like HLD, right? So in LLD, there is like schema design, there is entity relationship diagram, how we'll be using OOPS concept uses, and then design pattern uses. Then in HLD, we talked about the functional requirement, non-functional, then capacity estimation, API design, what kind of database we are going to use, and how our high-level component should be there. Okay, so this is very important for any of the interviews. Okay, so these are the two things which generally any company they follow. Like first thing is the importance of first thing is DSA, and the second thing is design. And design will include two things: LLD and HLD. Right. So if you have any question, maybe you can put chat. You can put your question in the chat, and then I will answer on those points. Yeah. So now I just wanted to talk about our last topic of this session, and that is like a resume build, right? So how we should build our resume. That is very important, because whenever you are going for any of the company, before your knowledge, what generally there would be first screening round, right? Because they don't know you. Okay, they don't know anything about you, they have just your resume. So that's a first impression. Okay, so how you will build your first impression, that's very important part, and that is the resume part. Okay, so you can see that the left one, I have just mentioned it like it's less effective, and the right one I have just mentioned it the more effective. Why? The reason is, you can see that in the left one we have like multiple pages, like maybe 4 to 5 pages we are having. Okay, so in 4 to 5 pages, it's very like it's kind of a very time consuming, right? If I want to screen some resume and I need to go to the 4 to 5 pages, minimum I need to spend 10 to 15 minutes, right, for one screen resume, for screening one resume, right? And in the right hand side, what I have done, I have just consolidated each and every information in one page, in a single page, like what skills I'm having, what is my work experience, maybe what achievements or certificates I'm having, my education, maybe my graduation or last one, maybe graduation or post graduation, whatever it is, maybe grad or post grad, right? And then generally I'll talk about my skills. Okay, and then organization and all, right? So this would be very effective, because I can consolidate, means I can see there is a centralized place, there is a single page where I can see each and every information on one page, correct? But in the left one I have like 4 to 5 pages, and we should not be using like too much table and all. The reason being, it takes a lot of spaces. Okay, so I'll tell you like in the next slide, generally how I prefer building the resume in one pager, or let's say max it's 2 pager. Okay, so that would be in my next slide. So yeah, now, so now the thing is, if I talk about the resume building, how my resume should look like. Okay, so the thing is, in the single page resume, very important point is to mention your, maybe if you are having some coding profile, like let's say you have CodeChef, HackerRank, or maybe any kind of a coding profile if you are having, then you should be mentioning that particularly. That is the first thing. Okay, now the second thing is, you can mention your details like email and phone number on the left. Like if I go to the previous page, then you can mention your few information over here, like let's say your email, your phone number, your LinkedIn profile URL, your GitHub URL, okay, or your coding profiles. So this space you can utilize it for having all the personal details, right? Like coding profile, email, phone number, and all of those things. And this should be at the first page so that anyone can see it here and they can contact you, they can send you an email, they can call you on this particular phone number, right? Or maybe let's say if they want to visit your LinkedIn profile, they can just directly click here and they can go to your LinkedIn profile and they can see what you can mention each and everything into your LinkedIn profile in a detailed way. And maybe if someone wants to visit your profile, then they can visit it and they can go through with that, right? Then what I can do, I can, so this is a place where I can mention all those details, right? Like coding profile, personal details, LinkedIn profile, my GitHub link. Okay, right? Now now the second thing is very important, which is your roles and responsibility. Like what is your current roles and responsibilities in your current organization or maybe in previous organization. So you can just pick a top highlighter, you can just pick a top 3 or 4 major major roles and responsibilities. Like maybe you would have worked on some API development, a very or maybe you would have deal with some API security. For security, maybe you would have used some MoveAuth framework, or let's say OpenID Connect or something like that. So you can mention those point into your roles and responsibility, whatever you have done. That maybe you would have migrated it from legacy to kind of new stack, okay, to solve some problem, right? So the major roles and responsibility, you can mention it into your resume into that particular category. Let's say if you are having into a multiple you would have been, let's say if you are part of multiple organization, and what you can do, you can have multiple organization here, and in each organization you can have specific 3 or 4 roles and responsibility. One very important point which I would like to focus here, that is open source contribution. Let's say if you have contributed to any of the open source, so definitely you should be mentioning it, because that's, yeah, it's really a great thing which maybe you'd have done that. So definitely we should mention it, our contribution maybe in any of that, so whichever you have done the open source contribution, right? And yeah, in work experience you can mention your roles and responsibilities. And skills, you can mention it like this, maybe what are the skills, maybe Java or Spring Boot or REST API or Spring ecosystem, something like that. So those things you can mention it here. So if you see here, so this is my skill section, this is my work experience, this is my certificate and achievement, this is my education, okay, this is my volunteer experience. If I want to mention, I can mention it, otherwise I cannot. And then maybe what kind of language, if you want, you can mention it, or it's up to you. Okay, so this will have kind of a single pager resume which you can build it. Okay, so if someone is screening, if someone is doing your resume screening, then what they can do, they can just go to line by line, means they can just go to a single page and they can read all those information, right? So that's how I'm just calling it as a more calling it as more effective, and this one I'm calling it as less effective. Okay, so this is about the resume building. So what are the top things? Like we should be mentioning our maybe GitHub profile, LinkedIn profile, and then any of the coding profile. Okay, what are the skills we are having? What's our work experience, organization name, and all. Okay, and then what was our major roles and responsibilities. Okay, right? And what is your achievements, what's the certification which you have. So those things you can mention it in one page. Okay, right. So that's all for I think today. I'll just quickly go through again like what I have talked about. So so this was a very high level tips, for a very generic tips for getting into any companies, any good companies, or any of your dream company. So the focus area should be DSA. First thing should be the data structure and algorithm, because I told you like what's the importance of data structure algorithm and why companies are looking for the people who are having good understanding, good knowledge of data structure algorithm. So that is very important. So that should be our first criteria. Okay. Second thing should be the design. And if I talk about the design, then design will include LLD and HLD both. So LLD, again, LLD, it means like low level design, like how you are designing your system as part of, in terms of the low level, how your class diagram should be, how your entity relationship diagram should be, what kind of design pattern you are using, how your schema will look like. So that is LLD. And then in HLD, definitely you will have to talk about whole system level, like how your system architecture should be, right? So that should be your HLD part, what all the components you are going to use it, right? So those are those things like which you can discuss into your HLD part. So while companies are looking for the low level and high level design, so that you can think on a particular problem, and you should be having ability to write the code in terms of the low level design, how you are thinking, how what kind of edge cases you are thinking on. So that will help you to doing LLD. And definitely HLD will work on at kind of a bigger or a system level. And then I talked about little bit on resume building, and like how we should be going for the either one pager or max to max two pager resume. Okay. And that should be kind of because having 4 page 5 page resume, that would be a bit lengthy, and screening people will have to spend a lot of time for screening it, right? Maybe, well, let's say for example in your introduction only you would have written like, let's say maybe 5 or 10 lines. So that's like kind of more lengthy process for the people who are screening your resume. Okay. And then I discuss about how our single page resume should look like. So these are the points which I have discussed. I think we can keep in mind. So this is my suggestion. So maybe you can just go through with that, and then accordingly we can build our resume, right? So yeah, that's all for today. And thank you very much. Thanks for joining in, and thank you all. So yeah. So if you guys have any question or any, uh, uh, then maybe you can just drop in chat. I will try to reply that. Okay. So yeah, that's fine. Yeah, you're doing BCA. Okay. So do you have any question for me? Okay, that's great. Yeah. ठीक है. You know DSA, yeah. Yeah. So even if you are doing BCA as well, then yeah, data structure and algorithm is very important. I think you might be having in your curriculum like what all the data structure or what kind of algorithm you are going to use it, because that is very important to write any optimized code, or right, to building a great product. So yeah, so definitely you should be having a proper understanding on DSA. Dev कब start करूं? So can you please explain this? Like maybe आप थोड़ा इसके बारे में और बता सकते हो? So डेवलपमेंट कब स्टार्ट करना है? लाइक एज लॉन्ग एज मे बी जैसे जैसे आप अपना डेटा स्ट्रक्चर और जो भी टॉपिक्स आप पढ़ रहे हो अकॉर्डिंगली आप उसके हिसाब से प्रॉब्लम सॉल्व करते रहो. जैसे फॉर एग्जांपल लेट्स से आपने एरे पढ़ा, सो आप एरे के प्रॉब्लम्स उठाओ और प्रॉब्लम को सॉल्व करना स्टार्ट करो. ओके. और आप लेट्स से मान लो ट्री पढ़ रहे हो, तो ट्री में पहले वो बेसिक्स ऑपरेशंस देखो क्या होते हैं, कैसे आप सर्च करोगे किसी एलिमेंट्स को, क्या इंसर्शन डिलीशन है, जो बेसिक्स ऑपरेशन है पहले उनको गो थ्रू करो, कंसेप्ट्स को समझो, एंड देन you should be picking some problem statement and then try to solve those problem statement. That's how you can have hands-on on data structure and algorithm. So yeah, definitely maybe you can have some notes and all, and then you can start preparing it like topic wise. Okay, the important concept, like let's say what are the different kind of iteration you have, what are the different algorithms. So you can just have it in kind of a centralized place, or किसी एक ऐसे जगह, मतलब आपका कोई एक नोट्स बना लो जिससे आप उसको आप रिवाइज करते रहो, राइट, सो दैट आपकी कंसेप्ट्स को ना भूलो। बट जो मेजर मेजर थिंग जो है वो आपका प्रॉब्लम सॉल्विंग है। तो अगर आप प्रॉब्लम को सॉल्व करते रहोगे आपके कंसेप्ट्स बहुत अच्छे हो जाएंगे, राइट। सो whichever topic you are studying, you just go and try to solve those problems. Okay, try to solve it. Don't look for solution, just try to solve it, keep on solving it. Thanks a lot. Yeah, thanks for joining in. Yeah, okay, so yes, I'm going to close this session. Thanks again for joining in, and yeah, see you in next session. Yeah, thank you, bye bye, good night.